Edge cloud resource allocation strategies. In the realm of edge cloud resource orchestration, resource allocation plays a crucial role in determining the efficiency and effectiveness of edge computing systems. It involves the distribution and management of resources such as computing power, storage, and network bandwidth, in order to meet the diverse and dynamically changing demands of users and applications. In this tutorial, we will dive into the various strategies employed for edge cloud resource allocation. 1. Centralized resource allocation. In this strategy, a central entity, such as a cloud controller, controls and manages the resource allocation across the edge cloud infrastructure. The central entity receives requests from edge devices or applications and decides on the allocation of resources based on predefined policies. This approach provides a centralized view of resource utilization, allowing for better resource optimization and load balancing. However, it may suffer from increased latency as all decisions are made by a single entity, and failure of the central controller can lead to resource allocation issues. 2. Distributed resource allocation. As an alternative to centralized resource allocation, a distributed approach can be adopted where each edge device is responsible for allocating its own resources. In this strategy, edge devices autonomously decide how to allocate their resources based on local information and predefined rules. The distributed nature of the allocation enables faster decision-making and reduces the dependency on a central entity. However, it may lack a global view of the resource utilization, leading to suboptimal resource allocation and potential resource wastage. 3. Hierarchical resource allocation. Hierarchical resource allocation involves dividing the edge cloud infrastructure into multiple layers or levels, each responsible for resource allocation within its own scope. At each level, a local resource allocator makes decisions based on local information and policies, while higher-level allocators coordinate resource allocation across the hierarchy. This strategy allows for better scalability and flexibility, as resource allocation can be fine-tuned at different levels of the infrastructure. However, it introduces additional complexity in managing and coordinating resource allocation across multiple layers. 4. Market-based resource allocation. This strategy adopts market mechanisms to allocate resources in a decentralized manner. Edge devices or applications act as buyers and sellers of resources, and prices are determined based on supply and demand. Market-based resource allocation fosters competition and allows for dynamic adjustment of resource allocation based on changing market conditions. However, it requires a robust market design and mechanisms to avoid manipulation and ensure fair resource allocation. 5. Predictive resource allocation. Predictive resource allocation utilizes historical data and predictive analytics to anticipate resource demands and proactively allocate resources. Machine learning algorithms can be employed to model resource utilization patterns and make accurate predictions. This strategy helps optimize resource allocation based on future requirements, leading to improved system performance and resource utilization efficiency. However, accurate prediction models are essential, and unexpected variations in demand may lead to suboptimal resource allocation. In this tutorial, we explored different resource allocation strategies in the context of edge cloud resource orchestration. Each strategy has its own strengths and weaknesses, and the choice of strategy depends on various factors, such as system requirements, application characteristics, and infrastructure constraints. Based on these strategies, edge computing systems can achieve efficient and effective resource utilization, leading to improved performance and user experience.